In this video, we're going to learn how to name enantiomers, or how we can distinguish between two enantiomers. So in the previous video, we learned that although we may name both of these molecules butane-2-ol or 2-butanol, same thing, they are not the same molecule. They are enantiomers of one another. And specifically, they differ in their configuration, their arrangement of atoms at the stereogenic center, the carbon that bears 4 different substituents, methyl, hydroxyl, hydrogen, and ethyl. And thus that carbon, having 4 different substituents, 4 different groups, it basically takes away the possibility that this molecule may have an internal mirror plane, and thus it has the property of chirality and has an enantiomer, a non-superimposable mirror image. So these two molecules cannot have the same name. They are not the same. So we must distinguish between them, and we do that with the RS system. One of these enantiomers will be the R, and the other will be the S. So first things first, we're going to identify the stereocenter, the carbon that has 4 different groups. So that is this carbon. And I'll go ahead and I'll put that implied hydrogen on there just in case. Now, on that stereogenic center, we want to look at the atoms bonded to it. So we're looking out one atom in every direction from the stereocenter. So I'm starting with this enantiomer. Okay, now that we've done that, we're going to rank those atoms based on the Kohn-Engeldt Prelog priorities. And this basically goes by atomic number. The higher the atomic number, the higher priority. So this will mean that the hydrogen is going to be priority 4 because it has the lowest atomic number. Oxygen will be priority 1, and then the 2 carbons, they tie. Now, for those 2 carbons, you look at what's bonded to them. The methyl carbon, this carbon, it's bonded to H, H, H. So I'm going to write that out eventually. Okay, H, H, H. And then this carbon, it's bonded to C, H, H. So we'll write that out as well, CHH. And this carbon is bonded to something with higher priority, so it wins. So this carbon will be priority 2, and this will be priority 3. Now, we want to make sure, so we're at step 3 here, that we're looking down the lowest priority bond. So basically, the lowest priority atom is going into the page, right? And so that's true here with hydrogen because it's bonded with a dash, so into the page. So we are looking down the lowest priority bond. And then you want to trace the path from highest priority to second highest to third highest, 1, 2, 3. And then look at the direction that path is going. So in this case, the path is going clockwise or turning to the right. And so this is the R enantiomer. And then we'll see an example where it's going counterclockwise in just a moment. So this molecule on the left, it is R butane-2-ol. Okay, or R is telling you the absolute configuration of the stereocenter. So we're going to try this again now. We're going to try this again for the other enantiomer. So we're going to start by identifying the stereocenter, which we've already done. We're going to go out one atom in every direction. We're going to assign the priorities. Well, hydrogen has the lowest atomic number. It's number 4, lowest priority. Number 1 with the highest atomic number is oxygen. And we've already gone through how these two carbons tied, but this one is bonded to CHH, so C and the two implied H's, and that beats HHH, which is what the methyl carbon, is bonded to. Okay, so step 1, step 2. Now we're at step 3. This time, the way the molecule is drawn, the lowest priority bond is coming out at us. So we need to take this molecule and we need to flip it over. I can do this on paper, but I've been doing this for a very long time, and so you might actually need to do this with your model kit for a while until you're able to flip it on paper too. It took me years to be able to do this in my head. A lot of using models and putting my head next to the paper and things like that. So now you want to put the priorities back onto the molecule. So we've already distinguished which atom is highest, second, third, and fourth priority. And then you trace the path, 1, 2, 3. And this time we can see the path is going counterclockwise or to the left. And so that means that this stereoisomer is the S isomer. So this is S-butane 2-ol. And this is what you're going to see. One enantiomer will have the R configuration, the other will have the S. They're opposites of one another. Great. So now you want to practice. So here are 3 chiral molecules. You should pause and follow the steps to assign R and S. Step 1 is identifying the stereocenter, and then you want to assign the priority of each atom bonded to that stereocenter. So here are the 4 atoms bonded to the stereocenter. The highest priority group is bromine. It has the highest atomic number, then chlorine, then fluorine, and then hydrogen. Step 2 is to look down the lowest priority bond. So I'm going to do something that you're probably going to hate, which is I'm going to draw a Newman projection down the lowest priority bond. So that's a little hydrogen in the back. And here are the other atoms on that front carbon. So chlorine, bromine, and fluorine. I'm going to put the numbers back. So 1, 2, 3. So just let you know, that little guy, that's hydrogen. And this is the carbon in the front. This is a classic Newman projection. And then let's trace the path. So 1, 2, 3. This path is going clockwise. So this was the R enantiomer. Okay, cool. Next molecule. Assign the stereocenter. Now we're looking out 1 atom in every single direction from that stereocenter. Awesome. Now we're going to assign the priorities. So hydrogen, that's the lowest priority, priority 4. And then, oh no, we have tie between all these carbons. All right, the methyl group, it's bonded to HHH. This carbon, it's bonded to CHH. This carbon, CHH. All right, well, that means the methyl loses, so it's the third priority. But we had a tie here, so we have to go out 1 more atom at least. So now this is bonded to implied H, implied H, implied H. So HHH. This one, CHH. Oh, yay, we finally have a winner. This side wins. Now, you might be tempted to say, oh, you can just do this by size. The biggest group is going to win. No, that will not work for you every time. So make sure you go atom by atom until an atom wins. Now, luckily, we are already looking down the lowest priority bond. So number 4, hydrogen is in the back. And then you trace the path, 1, 2, 3. You can see that we are going clockwise. So this is also the R enantiomer of that molecule. And now finally, for the last molecule, let's go ahead and assign the stereochemistry. So here's the stereocenter. We're looking an atom out in every direction. So chlorine, carbon, carbon, and then there's going to be an implied hydrogen, which I will go ahead and draw in for us. We want to assign priority. Chlorine is number 1. It has the highest atomic number. Hydrogen has the lowest atomic number. It is 4. You have a tie between the two carbons. The methyl group is bonded to HHH. The ethyl group CHH, so ethyl wins. And the methyl is our third priority. Now, you can see we are not looking down the lowest priority bond. So in the previous example, when that was the case, I had to flip it over, right? We flipped it until we were looking down the carbon group 4 bond here. Well, guess what? You don't actually have to do that. This is what you do, so you don't have to deal with that. What you want to do is trace the path. So the path 1, 2, 3. The path is clockwise. So it would be R, right? Except, oops, the lowest priority bond is coming out at us, so it's not R, opposite day, it's S. So this would be the S enantiomer. All right, just assign the configuration, and then if the lowest priority bond is coming out, just make it the opposite of whatever you assigned. Awesome. So now for these molecules, we could draw their enantiomers, right? This is the R, this is the R, this is the S. For each of them, we could draw their enantiomer. And in the previous video, we were doing that by imagining a mirror, and then we were drawing their mirror image. And that mirror image was their enantiomer, and so this would be the S isomer, for example, okay? If there's 2 enantiomers, one is R and one is S. But in a second, I'm going to have you do something a lot harder, which is I'm going to ask you to draw the enantiomer of something bigger with, maybe multiple stereocenters. Gasp. So is there an easier way to do this? Well, yes, there is. So you want to identify the stereocenter, and then all we're going to do is just switch the configuration of just 2 of the groups. So for this molecule, I'm going to leave the carbon chain exactly the same. And then I'm going to make methyl go in, and I'm going to make hydrogen come out. And that's super. Then I've drawn the S. And you can confirm it if you want. You can assign the stereochemistry and prove to yourself that we switched it. We have the S. Okay, same way for this last example. All I'm going to do is I'm just going to swap where these 2 groups are, but I'm going to leave the carbon chain exactly the same. So now, chlorine is going to be out. Hydrogen is going to be in. This would be the R. So I've drawn the enantiomers. And enantiomers are configurational isomers. So you interconvert them by breaking bonds. And that's exactly what I did. I broke this bond, and I swapped the groups, and that got me the enantiomer.